A square wave is a signal which alternates between two amplitude values. Typically, one amplitude value is positive and the other one is negative. By default, the positive amplitude occurs for half of a cycle and the negative amplitude for the other half of the cycle. But that doesn't always have to be the case. As the programmer, this is a parameter that we can set called the duty cycle. In Matlab, there's a built-in function for creating square waves. It's called square. In fact, it behaves very similarly to the sine function. Let's take a closer look. Here are some steps that we can use to synthesize a square wave in Matlab. Many of these steps will be similar to what we've done before with the built-in sine function. First, we'll create a variable for our sampling rate, 48,000 samples per second. We can use that to calculate our sampling period, or the duration of time between each sample. It's 1 divided by our sampling rate. Now we can use our sampling period as part of the process creating a time vector. This vector will contain the time in seconds for each sample in our signal. So start at time 0, we'll go up by a step size of our sampling period, and we'll say as an arbitrary choice that our length of our signal is 2 seconds long. Now we've created a horizontal row vector which contains the timing for each sample. Now I'm going to add an additional step here that we haven't done before, just as best practice. If we didn't do this, our code would still function. But when we're working with audio signals, it's a good habit for us to get into working with arrays that are column vectors instead of horizontal row vectors. So right now T is a row vector. It has a bunch of columns and one row. We need to reorganize it to be a column vector. Just rearrange where the samples are placed. So what I'm going to do here, one method of doing this, transposition, is to use T and then in parentheses, put this colon operator. Let's just reassign this to T. So we'll take that array, rearrange it, and then store it back in the same name. So all we've done is just changed the positioning of these samples. They still have the same values. All right, now we can move on. I'm going to create one last variable here, f, which is going to be our frequency of our signal, the number of cycles for every 1 second. We'll pick a value of 3. It'll be something that we can visualize when we go to plot it. Now we can use the built-in square function just as we've used the built-in sine function before. One thing I will say is that the square function is part of the signal processing toolbox in Matlab. It's an additional thing than the core package of Matlab. So if you don't have the signal processing toolbox, you can check this video out and still follow along. I'll post another video afterwards about how you can recreate this if you don't have the signal processing toolbox. But I will say there are some nice built-in things that make it very helpful and intuitive for synthesizing these types of signals. So here, we're going to use the built-in function square. Just as we used sine, we'll just replace the name of it. Now we're going to put in 2 times pi times f times t. All right, let's assign this to a new variable y. It's going to be our square wave. Now we should plot t versus y and look at the result. Here's our signal. It's a 2-second long signal, and we can count how many cycles it goes through per second. So one cycle is going to be positive 1, negative 1. And we start over again, positive 1, negative 1. We're going to oscillate between these two values. You can see that it goes through 3 cycles per second. So it's behaving in a similar way to the sine function. We just end up with different amplitude values. Let me show you one other new feature that's part of the square function that was not part of the sine function. It's called the duty cycle, and it represents conceptually the amount of time that we spend at the positive value relative to the negative value. It's a percentage. Right now we've got 50% of a cycle at positive, 50% of the cycle at negative, but we can change that. So here I'm going to put in, using that same function, an additional input variable. So I'm going to put a comma, and here's the percentage, 0 to 100 for the length of time we spend as a positive value. So let's put in 25 for 25% of the time being positive. let's go ahead and plot this one and compare the results. So now we can see that our signal is +1 for a shorter period of time and -1 for a longer period of time. I could change this one. Instead of 25, I could change it to 75 and plot it. Just look at the result. Now it's 75% of the time positive, 25% of the time negative. And that's called the duty cycle. The last thing I'll do, besides plotting it here, is let's go ahead and synthesize one that we can listen to. So I'm going to change the frequency from 3 to now to be 440 hertz, a frequency that we can hear. So we're going to go back and use square again. 2 times pi times f times t, and assign it to y. Now, instead of visualizing it using the plot function, let's listen to it by using the sound function, y, and then our sampling rate. Sounds like this. So those are the steps that we can use to synthesize a square wave using the built-in function for Matlab.